Thanks for the thanks for the invite and the opportunity to be here with everybody. This is, I think this is the first time I've been back to the Hot Interconnects conference since I think I presented a 240 gig backplane architecture here for the Nexus 7000 product line in like 2007 or 2008. And I was excited about the shift from 8B, 10B to 2426 encoding in that time frame or something. I mean, it's been a while. So I really appreciate the opportunity to be here and chat with y'all about what we've been up to. I'm gonna try to keep this away from too much marketing fluff, especially following that awesome presentation on MPI scale out and performance optimizations. It's like, okay, that's much more technical than I'm covering, but I we'll try to find somewhere in between and keep this away from the sales and marketing aspects too much. So short version we're going to chat about is networking in the cloud is kind of sucks, to keep it really simple, because we end up with a lot of constructs in the on-premises environment that have their own legacy issues. I mean, the configuration models gleaned from the 1970s, complete unstructure into the configurations themselves, poor or lack of adherence to consistent data models and so on. And then you go to the cloud environment, then you have each cloud provider doing their own thing. And again, the unique proprietary nature of some of the features lends itself to lack of consistent implementation. And what a lot of folks have been kind of driving and pushing us towards is, how can I build a consistent networking abstraction across this large multi-domain environment I have to deal with? I should be able to add 10 new VPCs to one public cloud provider and have those instantly be reachable, relatively instantly be reachable from other cloud providers and my existing data centers. Can I provision a consistent VPC architecture where a VPC in the public cloud has an analog in my data center, which might be a type 5 EVPN? And then can I guarantee end-to-end cryptography between them to protect the data sets, especially if they're in the same trust zones? And you kind of start seeing that the complexity of the environment gets rather profound. So this is an area like we had recognized the problem space, and we said we wanted to solve it in, I think, a fairly unique way. I mean, I've seen a few companies with some commercial offers in these areas that kind of lend themselves to like the glorified provisioning of static routes in Nginx instances, or turned out to be fairly controller centric. And I wasn't personally a big fan of controller centricity, because the failure modality of controller outages is a real pain, right? We needed to have an operating environment where the loss of centralized management, visibility, controller type things could happen without degrading the performance or even the failover capabilities of the federated systems. Our goal was to design a cloud interconnect capability using open industry standards, routing protocols, federated systems architecture, and designed for multi-vendor interoperability with no proprietary lock-in. So that became the core design points. The other one was to kind of look and feel and operate like a cloud function does, meaning I should be able to use Terraform to declaratively provision instances of VPCs, and then without having to do a lot of additional work, deploy into those VPCs router instances that could auto form into the topology, be booted off gold master images, be procured through marketplaces, be paid for on demand and consumed in a cloud style fashion, yet still be automatically provisioned with no human interaction to be fully participating elements of the architecture. So saying, cloud style tools and cloud native operator experience, yet fundamentally a network function with normalizing the connectivity abstractions across these environments. That was the sort of program goals. This hits a lot of wonderful adjectives of things we built, but that go along with it. I'll probably touch on a couple of things that are interesting. We are using VXLAN headers for in-band network telemetry, giving me delay, latency, jitter, drop rate measurements on a per pathwise basis, allowing therefore for flow-based dynamic path selection to load up particular flows onto paths and more effectively utilize the transit network environments that exist between cloud providers and between cloud providers and on-prem environments. Consistent network segmentation model was key, so we could establish a network analog to the dev test stage, prod sort of DevOps style structures and be able to promote workloads through that pipeline and have them be, different VPCs be resident in different transit infrastructure, oftentimes viewed in the equivalent of a VXLAN or VRF. Elastic performance, scale up, scale down is critical to cost optimization. And then further driving the visibility down even into the Kubernetes environment, where the routing substrate, routing protocol, BGP instances are moved down into the Kubernetes environment to orchestrate between the Kubernetes host and the top of rack switches for route health injection and reachability and so on. So it gives a bit of a flavor for it. Kind of what all goes into this environment. It's a lot of moving parts, to be very clear, and the goal is to make them all work well together. The other thing we did is I really wanted to optimize on stack simplicity. So I should have worn the sweatshirt that's in the closet behind me. It's a Beavis and Butthead sweatshirt, because we were jokingly calling it the Beavis stack, and we were trying to simplify the network stack choices as much as possible to BGP, EVPN, VXLAN, IPsec, MACsec, and segment routing. Recognizing that in this environment and in that entire really network architecture, multi-domain environment of campus and data center, branch, and WAN, I can use those same networking stack choices and generally solve about 80 to 90% of the networking challenges that we run across. And by reducing the complexity of the network stack choices, and adopting consistent pattern-based deployment models, it really lends itself to the rapid adoption and the highest value delivery from automation, right? Like automating snowflakes really sucks unless I'm using an RNG, but automating network architectures, the more broadly deployed a pattern is, the more value I get out of the automation we enable. So again, a key component of how we're looking at this. So, in short, the following kind of workflow happens. You can go to Terraform and you can say, I want 150, let's make it a rounder number in this case, 160 virtual private cloud instances, VPCs or VNets, depending on your cloud provider, back to the unique nature of each cloud provider's interaction. Terraform runs, let's take an AWS scenario, and we'll spin up a VPC, multiple availability zones. Some friends of mine work at Couchbase, so you're going to get a Couchbase example. Sync gateways, servers, ELB between them, off you go. Pretty straightforward. Terraform talks to Arista Cloud Vision as a service, a cloud-enabled service, which then, based on knowing, we run a Terraform provider that has this information and allows you to about 6 or 7 lines of scripting in the Terraform script, say, hey, I want to get a router. And I want a router located in each one of those subnets. The router is procured through the cloud marketplace, is booted off a gold master image. At that point in time, the router has 0 information in the marketplace about the tenant. The interaction between Terraform and Cloud Vision provides the tenant state information, which is used to composite the bootstrap configuration, render that config, and place that configuration into the EOS router device. At this point in time, what happens is the router then continues its boot process. The configuration points it to an EVPN route server, connects to the route server, gets reachability information for all other members of the segment IDs that it's a member of, call that the prod segment in this scenario. And it also uses BGPsec to get the keying information for the IPsec tunnels and exchange that keying information securely and locate it into the EOS router instance, and then build the secured tunnels across multiple paths between each VPC, transit VPC, different endpoint in the on-premises hybrid environment, and so on. So no human touches it, and in about a few minutes, 150, 160 VPCs are booted, networked, meshed up, interconnected, secured, and we're off to the races. The neat thing then is I can add a VPC on-prem, I can add a VPC in the cloud and any of the cloud providers, and without touching any of the other installed base instances, they also automatically get reachability information, cryptographic information, and join and form into the topology. So yeah, they all talk together. Go us. Works pretty well. The other piece is it builds a Pathwise tunnel. So it will end up with a tunnel path interface across, say, Express Route, one over the internet, one over Direct Connect, one to an Equinix Cloud Exchange, whatever. And then the traffic gets flow by flow, dynamically load balanced. The other piece we're adding to this is based on the class maps, adding the ability to understand the billing metrics associated with each particular path so that I could intentionally prefer a fixed cost path to a variable cost path. And if that information is available through the cloud provider APIs, automatically update that so that if some ops team, procurement team changes the billing model because they've entered into a long-term EA or something with a provider, that information would automatically flow into the quality of service metrics that are used for traffic allocation per path. So it ends up, kind of again, auto-forming and auto-norming off the concept that a source of truth does exist for inventory, billing metrics, and a lot of things we've always never really had access to in the networking world, which is kind of awesome. So then you end up with multiple VRFs as the most coarse abstraction, and then VXLAN within VRF for a more narrow abstraction of group and segmentation IDs between different VPCs, VNets, and so on. So effectively, each VPC would generally map to one and only one VRF, and I'd be able to promote a VPC from one VRF to another and increasing or decreasing the security controls applied to it and aligning it with a particular trust zone. That's worked out in practice. This has worked exceptionally well with clients up to 4,000 VPCs across all major domestic cloud providers and hundreds of on-premises instances. It's worked when disconnected from the CloudVision system, maintaining full availability, and device or link failure times are generally detected, or path failure times are detected almost instantaneously with failover in the millisecond range, and nodal failures, if redundant, happen and are sub-second, usually sub 50 millisecond failure in those scenarios. So again, it's worked at very high scale, interoperable across vendor environments, terminated onto Palo Alto networks, devices, and so on the enterprise campus handoffs and so on, and extremely deterministic failure and scale up scenarios. So in the end, you end up with an environment that kind of looks like this, right? A big production segment could be segmented at whatever granularity the enterprise wants, EVPN route server controllers, CloudVision in our scenario operating as a management plane, as well as a receiver of GNMI gRPC state streaming telemetry from all nodes. So we have at least a 90-day look back into operating state of each element. And then I'm able to deconstruct, like, maybe very blunt, I don't think what this enables is abject data portability from one provider location to another. It's not like you're gonna, I don't know, live vMotion a SQL database from my on-prem data center to the cloud or something ridiculous like that. Once upon a time, I thought that was possible, and I was an idiot. Not really that possible. Data gravity is real. The more likely scenario is what I'm kind of describing here, which is, developers may have a preference for particular proprietary cloud services or functions. Cloud providers may offer unique financial commercial incentives to utilize certain services. And so you may choose to use those. If you're a big fan of Azure ML, you use Azure ML. If you love, Amazon, web services, web apps, you might be spinning some of those up and using their containerized environment. And you might end up with SQL databases that run on-prem more cost effectively than anywhere else, and it's already paid for. The ability to consistently interconnect and network those in a secure fashion that is auditable with high assurance is the challenge, and the ability to handle the dynamic environment of adding and removing nodes, segments, IDs, VPCs, and so on to different locations, and ensuring that the network topology auto forms to that is a key problem area that gets solved. So I think I'm actually coming up about the end of time. So, kind of a couple key projects we see a lot of folks focusing on, network automation and developing sort of a CI. We joked that CD was continuous destruction environment. Being able to normalize the connectivity abstraction in the cloud environment, enabling that automation to work at scale across the breadth of the environment we as networking professionals are required to interconnect and support, while maintaining regulatory compliance, full auditability and traceability of everything that happened, has become pretty key. So the areas I kind of home in on, and then from an observability perspective, it's getting all the data out of these environments so we can prove what was able to talk to what when, and also ensure that we're able to get accurate root cause analysis on first failure scenarios. The bottom one, I think there's a ton of room for us to improve as an industry. Secrets management and then cryptography, auditable cryptography, ensuring there's no gaps in coverage. Those are all areas just as an industry have to continue to improve it. Because a lot of us are our systems are hung in the 70s, 80s. I joke I'd like to see us get into the 90s from a security perspective related to switch router management and so on. But any questions at this point? I do want to kind of keep us on time track and not turn this into a glaring infomercial from a vendor. Instead, hopefully this was of use to people.
Thank you, Doug, for the talk. Yes, are there any other questions, people? Maybe you can display one of your last slides so we can encourage questions. We wanted to, so I don't see any questions there in the Slack channel or in the Zoom chat, but I have a question for you. What is the current source of, what is the current source of that keeps you up at night, basically worry about deploying this technology? What is the current source of bottleneck that you see? Basically, what technology, what are the areas that you need to improve to deploy this the VPC, to do a better job at it?
I think there's three things that kind of worry me, Oscar. Specific to the cloud native environment is that the rate of change in the cloud providers is kind of the tail wagging the dog. Like we're having to force fit our network architectures into the proprietary capabilities that are offered by a wildly diverging set of providers and offerings, and just maintaining a coherent network environment in there is a real pain. Kind of up leveling one spot, I'd say most, 80–90% of network outages are caused by humans, and most people don't test network changes prior to deployment. So I'm trying to affect a more opinionated adoption of a CI pipeline, and ensuring that even if I'm on a box typing config T and interface loopback 0, changing the address to something, that kicks off a pull request rather than bypasses that CI pipeline. I'd like to see, industry-wide improvements into changing the operating model to encourage tests, to encourage sources of truth, to encourage, better hygiene practices around network management. And then my worst case scenario, the thing that actually does keep me up at night and has too often in the last year, is that I was on a call with some of our government friends a few months back. You could probably imagine what weekend it was. And the question was, if somebody owned the network management system, could they own my switches and routers, stay resident on them? And if they were resident on them, could they bypass every single security control we had, steal data off of our network, and use it as a launching pad to any trust zone? And unfortunately, the answer to that question is yes. Almost every switch and router you have runs Linux. Nobody does a decent job patching and maintaining and mitigating the vulnerabilities. If you did, you'd be doing an emergency change control every week on most major vendors, and that would just really suck operationally. And so we end up with effectively wide open Swiss cheese systems out there, and there's not a single IPS system that validates, does my network device do what it's supposed to, and is only doing what it's supposed to, and nobody's stealing data off of it or staying resident on it. That's what actually keeps me up at night.
Yes, excellent points. And do you see any technology trend that is going to help mitigate some of those pain points from the?
Honestly, I am absolutely effing frustrated on the last one, because there's nothing I'm talking about that requires invention. Everything I'm talking about is the art of systems integration and systems engineering. These are solved problems. We've known how to do secure boot for 20 years. We don't do it, right, as an industry. I mean, when's the last time you looked at every process on your switch and router and validated the process integrity, and there's nothing running on it that wasn't supposed to be there, right? The fact that I could stay resident on some company's switch or router, bypass VLANs and VXLANs, steal data off of it, modify log files, and you won't know, is really, really concerning. We have to get better. So, I mean, what could we do? Take it seriously. Hold us as vendors accountable on the number of vulnerabilities we inflict upon you, but more importantly, how we treat you when we do. Are they fixed with a patch, or are they fixed with a complete binary upgrade? right? How many times do I make you do that in a year? How easy do I make it to automatically fix those? So you can at least keep a decent hygiene on your environment from known vulnerabilities that a script kiddie who's 13 years old can read about on Reddit and re-execute against your environment. Yeah, we got to get better.
Yes. We have a question in the chat. I don't know if you're able to read it. If not, I will.
Yeah, sure. Do you see very many multi-cloud deployments in practice? Each cloud provider has their own redundancy guarantees, use block pricing benefits, diluting usage across providers, and engineering teams aren't a fan of learning multiple stacks. Yes and no. I have numerous large Fortune 100 accounts worked with where the average number of cloud providers in production exceeds 4. 80% of the Fortune 100 exceed 4 cloud providers in production. Because now the question is, how often does the networking team provide the interconnection across them? And you're right, there are sometimes a cloud provider will come in and try to buy the business. But I tell my customers this, I go, please don't use Arista for everything. Keep multiples vendors in there and hold us accountable. That will make us better. If I was managing my IT supply chain, I would always ensure I had 2 vendors qualified for every piece of my production infrastructure, or I have a vendor concentration risk. The same thing holds true in the cloud. If you're bluntly sitting at a university dealing with a non-critical system that you're managing and you want to consolidate all of that into one or a single cloud provider because they give you a sweetheart deal, knock yourself out, man. That's cool. If you're a hospital and you're dealing with patient care, I wouldn't want to go to a hospital that outsourced everything to a single cloud provider when we watched a DNS screw up take an entire region out in the Northeast.
Yeah. So thank you for answering the questions. Are there any other questions?
I have a lot of opinions.
But it's good to.
Very happy to share them.
Yes. All right. I don't see any more questions, but the audience, please feel free to ask questions in the Slack channel, and we basically either we will forward them to Doug and
I put my email in there too, gang. And if yes. Really, but totally accessible. If anybody has any question or just wants to follow up anytime. I really have always loved this audience, and you're the guys doing the really cool stuff. So if there's areas we can improve or do better, I'm very open to the feedback. And if there's just a cool idea you want to bounce around anytime, that's fun. I'll grab a latte and we'll have some fun with it. So I really appreciate it.
Okay, excellent. Thank you very much for your talk. So we are about to